Here we're given f of x equals 1/4 x cubed plus x plus 1. For part A, we're asked to determine the value of f inverse of 5 without finding f inverse of x. And then for part B, we're asked to determine the value of the derivative of f inverse at x equals 5. So looking at our notes below, if f of a equals b, and f of x is differentiable at the point a comma b, and f prime of a doesn't equal 0, then f inverse of b equals a, and f inverse is differentiable at the point b comma a, and the derivative of f inverse at x equals b equals 1 over f prime of f inverse of b, which also equals 1 over f prime of a, because a is equal to f inverse of b as stated here. So we can use this theorem to answer part A and B. To answer part A, we use the fact that if f of a equals b, then f inverse of b equals a. So if we can find an x value where f of x would be equal to 5, we can then determine f inverse of 5. So let's actually make a table of values, where we'll let the first column be x, and the second column be f of x. Again, we're looking for an x value where f of x would be equal to 5. Well, if we let x equal 0, we can easily see that f of 0 is not going to be 5. It would be 0 plus 0 plus 1, or 1. So because f of 0 equals 1, this does tell us that f inverse of 1 equals 0. But again, we're trying to find f inverse of 5. So if we try x equals 1, we can probably easily see this is not going to give us a function value of 5. F of 1 would be equal to, this would be 1/4 times 1 cubed, which is 1/4, plus 1 plus 1, that would be 2 1/4, or 9/4. So because f of 1 equals 9/4, this does tell us that f inverse of 9/4 equals 1, but again, we're looking for f inverse of 5. Let's try x equals 2. Let's show some work on this one. F of 2 is equal to 1/4 times 2 cubed plus 2 plus 1. Well, this would be 1/4 times 8, which is 2. 2 plus 2 plus 1 is equal to 5. So we found the value we needed. F of 2 is equal to 5, which also tells us that f inverse of 5 is equal to 2. So for part A, we'll say since f of 2 equals 5, we know f inverse of 5 must equal 2. And now to find the value of the derivative of f inverse at x equals 5, we'll use our formula here, where the derivative of f inverse at x equals 5 is equal to 1 over f prime of f inverse of 5. But now we know f inverse of 5 is equal to 2, so this derivative function value is equal to 1 over f prime of 2. So before we find this, though, let's look at what this means graphically. The given function f of x is graphed here in red. The line y equals x is graphed here in black. So to graph the inverse function, we can reflect the red function across y equals x, which gives us this purple function. So this purple function is f inverse of x. And for part A, we found this point on the original function, 2 comma 5. And from here, we found the corresponding point on the inverse function, which was the point 5 comma 2. So this point represents the function value f inverse of 5 equals 2. And now the formula for the derivative of f inverse of x is telling us that the slope of the tangent line at this point 5 comma 2 is equal to the reciprocal of the slope of the tangent line of the point 2 comma 5 to the original function. And that's what this derivative function value is here. This is the reciprocal of the slope of the tangent line at the point 2 comma 5 to the original function, which again will give us the slope of the tangent line to the inverse function at x equals 5. For our next step, we'll find f prime of x. So f prime of x is equal to, well, here we'd multiply by 3, that'd be 3/4. Subtract 1 from the exponent, so that's x squared. The derivative of x is 1. The derivative of 1 is 0. So now we need to find f prime of 2, which would be 3/4 times 2 squared plus 1. So here we're going to have 3/4 times 4, that's just 3. 3 plus 1 is equal to 4. So for part B, we have the derivative of f inverse at x equals 5 equals 1/4. So going back to our graph one last time, we just found the slope of this green tangent line to the inverse function at the point 5, 2, which was 1/4. And we found this by using the fact that this slope is reciprocal to the slope of the tangent line to the divisional function at the point 2, 5. The slope of this green tangent line is equal to 4. I hope you found this helpful.